Hello everyone, Marcus here from learndatasciencegear.com. So in the last video, we trained our logistic model and then we calculate the accuracy score of our model. And then in this video, I'm going to show you how we can load in the trained dataset, and then we will ask the model to do the prediction for us of whether people will leave a company or not. And also as a bonus session for this video, I'm going to show you how you can do machine learning without any coding at all. So for that, we are going to use a software called Orange, and if you are interested to learn how to do it, please stay tuned to this video. So let's quickly load in our train dataset. Sorry, our test dataset is equal to pd.read_csv turnover test.csv and then df_test.cat. So we have loaded in our test dataset, which is similar to the train dataset, except that now we have the ID column, which is not useful, and then we don't have the left column because that is what we want to predict. So we can basically drop the ID and names, and then we can take the rest of the columns as input variables to our models. But then we also have to remember to turn the row and salary into something that the model can interpret, because they are now still in the something that the model could not interpret. So we will use the label encoder for this. So to do that, let's go ahead and I will copy the code here. We will drop the ID and names, and then we are going to create the object data frame with only row and salary, and then we are going to use the scikit-learn label encoder function, and then we're going to do the same thing as we have done before, in which we want to turn these two columns into something in numerical format, and then we want to drop the original column, the row and salary, and then after that you can run df_test.head. So you can see that we have satisfaction level, last iteration, blah blah blah, and then we have two new columns which are created by label encoder. So sales is 7, technical is 9, low salary is 1, median salary is 2. Yeah, so now we have our test data set, and then the next thing that we want to do is to scale the data and then feed into our logistic regression model, and then we will ask it to predict whether these people will leave the company or not. So to do that, so xtest is equal to our data frame, but then we are going to take only the feature columns, which are these columns, and then we are going to scale it, and then we're going to ask our model to predict based on these input variables, and then we assign it to a variable called predictions. And then we create a new column in our test data set called left predict, which is equal to our prediction. So then we can compare, and we can see that there will be a new column added to our test data set of whether a people has left the company or not. So if we run that, and then we are going to say df_test.head, we will be able to see our result here. So we can see that whether each guy, whether they will be leaving the company or not. To see more data, we can say 20. So you can see that there are some people which the model give a 1, which means that the model predict that this guy is going to leave the company. Then we also have 1 for this guy. Cool. So yeah, so now if you are the owner of this company, you can basically based on this model to predict whether certain employees in the company is going to leave the company or not. And if the model say yes, you probably want to do some actions to prevent good people from leaving the company. And as I mentioned, I also want to show you how you can do logistic regression or machine learning without using any coding at all. And for that, I want you to quickly go and download this Orange for data science. So if you search Orange data mining, you will come to this website, and then just go ahead and download Orange. I have already done that, so I will not do it again, but I'm going to launch Orange, which will take some time. So Orange is a software that you can install in your laptop, and Orange allows you to do machine learning or data analysis without any coding at all, which is super cool. So I'm going to I'm going to show you here, and then this will be the interface the first time that you have launched Orange. And I'm going to use Orange to basically do logistic regression with the same dataset, which is a turnover dataset that I have shown you in the Google Colab just now. But for this time, I'm not going to use any coding at all. So to do that, first you import. What is cool about Orange is that you can just simply click and drop any things that you want to use, any functions, for example, any data processing functions. There are also a lot of visualization functions, machine learning model, evaluation function, and so on. So this is super cool. I like this software very much. So the first thing that you want to do in Orange is to load in your dataset. For that, you can just click and drop CSV file import, and then double click it, and then you'll be able to select the dataset that you want to import. For example, turnover train, open it, and then you will want to make sure that the left column is selected as categorical, and then the rest of it you can leave it as default. Click OK, and then close it. So the next thing that we can do is you can just click and pull it out, and then we can select the next function that we want to do. For example, we want to see the distributions. Double click it, and then you will be able to see the distribution of different variables, and you can select you want them to be split by left, which is very cool. So in this case, you can see that satisfaction level between 0.3 and to 0.5. A lot of people were leaving the company, and then for number of project, you can see that 6 and 5, 6, 7 number of project. A lot of people are leaving a company. Average monthly hours, you can see that between 120 and 160. A lot of people are leaving the company. Same for 220 to 300 number of hours. A lot of people are leaving the company. So other than that, you can also look at correlation. If you double click it, and here you can look at how different variables are correlated to other variables. This will be very useful in terms of if you want to investigate whether certain variables are interrelated to each other, and that you want to make sure that you don't use all of them in your input variables to prevent multi-collinearity issue. And one more thing that you can do is probably feature statistic. So from here you can also look at the distribution of different variable, and then together with some statistical data that you probably want to look at. Super cool. So the next thing that you want to do is to select columns, double click, and then from here you can define what are your feature columns, which are the columns that you want to use it as independent variable to your regression model, and then what is your target variable, which is also your response variable. So we are going to leave out names, rows, and salary here because we don't want to use them for this example. Okay, and then the next thing is to test and score. So if you pipe the data into test and score, you will see there is nothing inside here because we haven't trained our model. So to train our model, we can basically go to model, and then we select the model that we want to use, and then in this example we want to use logistic regression, and then we can put it to the test and score to let our model to learn from the data. So if you double click it, you can see that we have AUC, which is area under curve, then we have CA, which is a classification accuracy. Basically we want it to be high, and then the area under curve we want it to be more than 0.5, and then we also have precision and recall. So precision and recall is something that is sometimes a bit confusing, and for this example we actually want to look at recall. We want the recall to be as high as possible rather than precision. Of course we want sometimes we want both of them to be as high as possible, but what is the difference between precision and recall? If you just Google, and let me show you in this article, they have explanation of what is the difference between precision and recall. So it's something that is related to false positive and false negative. And it takes a little bit time to load this page. Okay, so we have precision and recall here, and you can see that precision is defined as true positive divided by true positive plus false positive, and the recall is defined as true positive divided by true positive plus false negative. So true positive simply means that for this example, a people is planning to leave the company, and then your prediction says that he wants to leave the company. So this is true positive. But then false positive means that a person actually doesn't want to leave the company, but then your model predict that he wants to leave the company. And then false negative simply means that a person has a plan to leave the company, but your model didn't actually predict that he want to leave the company. So in our example, we actually want the as less false negative as possible, because we want to be able to predict as many people who wants to leave the company as possible. So so in this example, recall is more important than precision, but then this is only one of the example. In some other example, maybe you have precision that is more important than recall. So if you go back to orange, and then we have concluded that recall is high, which is good, then we can close it. And then the next thing that we want to do is to probably look at the data table. So data table will allow us to see how the model is doing its job. So you can see that this is the logistic model prediction for each individual data. So some of it, how it was trained, and then yeah, some of it predicts 1, and then the actual data is actually 1, and then some of it, if it predicts 0, some the actual data is actually 1. So you can review through this data table to see how the logistic regression model makes its decision. That is something that you can visualize in the orange, which is super powerful. So now we have our model being trained, and then the next thing is that we want to also load in our trained test data set, and then to let our logistic regression to make predictions. So to do that, what you need to do is to from the select column, you can select logistic regression again, and then we are going to import in our test data set, and then make sure to change no, you don't have to do anything. Okay, close it, and then pipe it to yeah, something that you have to do here is you have to define a prediction and then pull your data to the prediction. So what basically the model will do is based on what it has learned, the model is going to make a prediction based on your trained data set. So if you want to see the predicted result, you can just double click this, and then from here you can see what the model is predicting for each people. Cool. So I have basically shown you how you can do logistic regression with using Python in Google Colab. I've also shown you how you can do the logistic regression without any coding, and I think I want to stop here for this tutorial, and in the next tutorial I'm going to show you other machine learning technique. And if you like my video, feel free to click my like button and subscribe to my channel. And if you have any questions, just leave your comment below. I hope to see you again in the next video. See you.